Hey, what's up you again guys? This is Paul from Maharlikans Code. I'm a web developer, programmer by profession. I'm from the Philippines but working here in Singapore as a software engineer. And today I will walk through with you guys on how to use Gob Encode in Golang. Gob Encode is very important guys because in our previous discussions that we use the struct and then we use the struct and then we store all the in our demo, in our example is the this personal information struct. Then we store it in a Golang maps so that we can store multiple data into the maps. It's like the maps is the Golang's collection of all the information stored in the memory. But right now as you can see in our last discussion, the Golang's map is we can store only one struct data at a time, and I need our values. The maps is the key values, but the values there is we store only some like that in int64, and we store only one data. But right now we want to store and the entire struct, like those last name, first name, all the informations in the struct, we want to preserve it and store it into the map, and then as a value. Remember that the Golang maps is a key then value, unique key and then its value. But this value, this is we can store the entire struct, like the last name, first name, whatever the structure there, we can store it there. When we retrieve, for example, the username, and then it's all the personal information of the user, for example, then we want to store it into the map. But right now we can do that by using the Gob Encode, and then we decode it after that. So stay tuned for this guys. Okay guys, welcome back to the channel. And I prepare a small structure here because we know from our previous discussion that we have this person struct and then the person data. So we all have this. So we know all these things, but right now I'm adding the the sync mutex. This this one is very important guys, because this sync mutex, we every time we have this struct, as you remember that we have this the struct is just a structure collection of all fields. We need to collect all these username, first name, last name, all these things. And then in our previous discussion, as you remember that quick recall that the struct can take only one recent or latest data at a time. And then it will just replace over and over again if there is a new data that will come. If you pass on this person struct, if you fill in all this information, then it can store only the recent one, then it will not keep the previous. Right now and then after that we need to store it in the map so that we can this map can store multiple data. You can collect all the data from whatever you want to store there. Like in our case is this person's data. We intend to use this after the user key in all the information, and then we store it into the map. But right now it's a bit different. There's some small changes, like this person's data is another type of struct that I created. And then we need to have a key only. As you can notice that we only have one or two rows here, two fields for this struct. Right now, as you can see, there is a username here that serves as my field. Then there's a username there also. I just want to match these things because later on we can search through username or whatever you have, as long it's a unique key here or something. Then you can store, as you can see that the type is no longer the string or int or these are all the common one. You can store multiple here, guys. You can store interface, you can store interfaces, maps, functions in the struct. So pointer also, whatever, guys. Struct, then another struct. But this time is we store a map with a key string, which is the string here. And then as you can see, this is a byte. Right now in this topic is we are using the Gob encode, but we need to store it as a byte. Okay, guys. So this is the map, and then this is our field. So we want to store here all the maps into this field username. So okay, guys. So moving forward, then as usual, our email here is just a normal struct to store here in our previous discussion for the username. And then right now we need to type another type. I just call it st, guys. This is for the uh, collection of we need to accept some interface to store some uh, this one is another map also. So we want to store a string here, and then we can put interfaces. So interface, then we just leave it blank first. We initialize it with blank data. So again, the hint there. Um, this one, what they call is a map collection. Just put something like this. Types, sure. To format or something, guys. To format. Uh, whatever, guys. This one is you can just added later. This is our purpose to collect another thing later on. I will demonstrate to you. And then another one is we declare all these another variable here. Then we use the person's data here. As you remember here on top, this is the main struct that we want to store all the encoded gob encoded or in gob encoded uh, bytes. So we use this var pd is we want to shortcut the person's data because we can initialize some variables so that we don't no need to every time you use this person's data you no need to full like the full description or full name of this struct. So this serves as our shortcut for this one. So okay, then we use the username there, as you can see. Then we can make a map here, guys. This one is our initialization also. Then what do you call is another byte. Okay, guys. Later on, we'll be having this information again. This one initialize the person data struct with an empty values, something like that, guys. And then I need to create. Right now, we need to create another function. This function will serve as we can add, we can get, we can remove the map there, and then we can encode and decode the gob data. Okay, guys. So we use the person data here as our pointer. This is one of the we can call this as a chaining, guys. Predefined for our chaining functions or in Golang. So we have a separate discussions about this. So at the moment, just bear with me. So this is our encoded bytes. And then we have our bytes. This is the bytes. So we have two arguments for this function, because this one is the we need to add some okay, add to insert new row to the map collection, to this map, guys, person's data, because we use this map collection called person data. Okay, so um this one we need to check if the length, this is the length, guys, if strings the trim space. So we need to trim if the username is empty, then this is one of our validation, guys. We want to have a non-empty username as our argument. So p.mu, as you can see, I'm using this p as a person's data. Whatever you have, guys, as you can see, p, we only have two fields there, the username and the mu means the mutex. This mutex is very important, guys, because in Golang's map, when multiple users at the same time accessing this map or accessing this specific key, and most especially this map, these collections of maps, we need to lock some the rows that we are about to add or something, this, because there's some changes in the Golang's map. We need to take extra cautious, because for some multiple access at the same time, so we want to prevent this. So Golang itself is locking the data, and then it will commit all the changes. So these are all the techniques, guys, for accessing multiple. For example, if you have millions of billions of users at the same time, like you are a giant company like Google or something, then multiple users at the same time accessing the same uh, collection of maps, or this one is all in the memory. So this one is very quick one, guys. So we need to lock first, and then okay, then lock, need to lock data, then before then we can defer, means this is the uh, it will unlock by itself, guys, no worries. Then it will release back, then we can just if no this defer is it will just the Golang itself, this is the built-in Go command. So if this one is when they lock the user, something like that. If you open a file, and then you need to or open the database or open the connections, this defer will always be there. You always remember to put the defer, because if this you don't use the defer close or something, like for example in this case is a memory, it's just it's forever there is locking or something, or opening the database, then we there's an idle connections or whatever, guys, then it will just be there, is never close anything. So we need to in our case is we need to unlock, because we lock and then we unlock, this deeper will close by itself, guys, so no worries. This one is a standard for Go, especially if you open a file also, something like you open multiple one file with multiple users, then this is a problem. So you need to have a deeper, something like a file that close or something. This is very useful, guys. It's very common in Go also. So right now we need to proceed. P that username. Then we store the new username here from the arguments, from the function arguments, and then in bytes. This is the encoded bytes. Oh no, equals. So okay, guys. So oh sorry, this one should be open close bracket. Okay, so we have done the function. Another one is we need to add another function. It's still at this. Okay, we still need to use this person's data, and then we need to have a get function. This time is still username, guys, because this get is very useful when we get the some key in the map. Then we need the bytes there, and then the boolean. So now many information, guys. So later on, you can always look back to this video later. Then okay, then we need to have the p username. As you know, this is our previous discussion, guys. To search or look for a certain key in our map. In our last discussion. So okay, not equal to okay. Okay. This one is I just say it's a task data, or shall we say it's a person's data, guys. This one is more relevant. Personal data, person data. Okay, and then we return this okay. Then otherwise we can return the person data, then still okay, whatever, guys. So the um gets the specific username as the key to return something, guys. Return the value. Okay, then after that another one, we need to have this add, get, then remove, guys. We need to have another function called the remove. Again, we still need to use this person data, and then we need to have a function called remove, and still our key is our username, guys. So then we return byte, and then boolean also, and then I think this one no need. We just return the bool only, guys, because this one is a remove only. Okay, and then as usual, we need to use the mutex there, and then the lock, and then we defer p dot mu dot unlock. Okay, so but this time we don't use the error there. We just use the p, then the username, and then the username parameter. So we need to remove this username. So if not okay, then we just return false, guys. Since this is we return with the false with boolean only with the true or false. Otherwise we return, or otherwise then we delete, guys. As you remember, this one is from our last discussion. We delete with the what do you call, with the username, with the match with the parameter. Okay, so and then we return true. Yes, right now this one is deleted from the map, guys, from the person's map. Looking for this key as our username, and then the arguments there from the user's input. Then if the both username match from our map collection there, then we can just delete that one from our map. So this one we just put remove any specific username, or just a key using the username. Okay guys, that one we can enhance later. And then this is the important part guys. So you need to create the what they call the encoded payload. Now we need to use the what they call the gob encode. So at this moment we need to create a new function called encode payload. This is something like we need to store it in a payload guys. Then the person data. Okay, the person is here. So this is the person guys. As I mentioned earlier, that this is our struct. This is our, remember that this is only store only one current record at a time, or current data at a time. So right now I want to preserve this whatever it's stored in this memory, in this struct. I want to encode this into gob encoding so that later we can extract. Okay guys, so person, and then we use the person, and then I need a byte here because our map requires a byte. So you remember here in our person data, our value, this is our key from the map. Our key here is the username itself. Here is a byte, the exact byte of this, because we need to compress this or encode this into gob data. This gob encoding in Golang is very powerful guys, because you can encode the exact whatever you have a data here on the structure, it will just preserve guys. Okay, so we want to preserve this person's data whenever we have the collection. So okay, let's proceed. Var data bytes here guys, and then we use the bytes as the buffer. This is the standard for gob encode guys. So we just follow, and then new encoder. Then we need the payload. Okay, okay, then we need this payload. We need to encode, and then error guys, declare all these variables. Then we use the int there. We just use the hold on, new encoder, and then we continue guys. This one should be the encoder, and then we need to use the payload. Then after this is I need the data here, not the payload first. We need to store the data, the stream, this buffer guys, the bytes buffer. And then after this, if error not equal to nil, to check if some error is there, then we need to return guys data dot bytes with an empty, oops, then error, because we return errors and the bytes there, but we return with an empty bytes if there's some error guys. Otherwise we return with the data dot bytes, and then just a blank there is null. So this one we need some later on guys encodes the person struct collection. Then after this we need to have the decode guys, then we can use from our demo later on, decode payload. Then we need to have a username again as our key here, because we need this key so that we can decode the data. And then we need the person here. This person is from our struct guys, so the exact the first name last name, that that struct. So we need to check if the, again guys, we need to check the thing, strings, strings that trim space, this username, if it exists or not, exactly equal to 0. Then we return the person with an empty struct, then errors dot, no. Then errors dot new. Then we say something like a username username key is not what do you call, is required. Okay, so this is just a normal validation, guys. And then we need to use the bar here, bar payload again, and then the person data with an empty one. Need to initialize first payload. Now is the bytes, guys, and then we just ignore the error first, and then pd. As you can see, we need to use the pd already, guys. So the shortcut, the pd is here. This one is from our person's data. This is the map, and then the string. This is the actual collection, guys, of the map there. As you can see, where there is a make then map string here. Okay, so right now we need to use this pd to get the data. As you can see, we use now the get function, guys. Early on we created the function on top. Then we need to use the, this one, this is the decoded variable here, so we throw all this here. Go that new decoder. Now we need to decode. Early on we have this go new encoder here, because we want to encode this person struct. Then after this we need to decode back or extract the data again, whatever it encoded here, into the bytes, into these bytes, guys. So right now we need to use the username as our key, and then we use this struct again. That's why if you have changes here, you cannot decode, because it will throw you an error if you change the last name or even the spelling or whatever the types. The moment that it encodes the data, then you change something, then you cannot find. But this one is that's why it's more secure also, guys, and then more faster. Okay, decoder. Then we need the bytes here, guys. A new decoder. So this one requires a bytes, and then a new reader. This one, and then we use the payload bytes. Payload. These bytes. This one. Then after this is the, need to check the error, guys. Error is equal to decode. Then we pass on this payload here, this person, because we initialize it with variable. Easy for us to maintain. Not equal to nil, the standard error. If nothing there, is there some error, then we just throw with an empty struct. We don't return anything. Errors.new. This is our custom error message, guys. Username key is not found, because otherwise then we throw the username there also, so the user may know what is that, cannot find this username as our key. And then we just return, guys, with the normal one. Then we return the payload if no errors. Then this decode here extracts the data. extracts the data from the person structs. Okay. Now I want to create a new our main that function here in the main func. So we want to test, guys, the thing. So we would like to add here, guys. We try to add the new data first. Okay. Right now we cannot direct, but I would like to add a new function first. Prior to our discussion. You remember that we have this function. I shortcut a bit, guys, so that we can short our time. I created this new person data again because you know how we previously we added this new person to create to use this function and then to insert the new personal information like that username, first name, last name, age, and then our username. Right now there is some small trick here. We need to encode the moment that the new person has been added into this variable. We need to use this because this is now our data for the new person. Right now I want to encode this entire data and then encode this using the Gob encoding in Golang. Then after that it will store into our map. As you remember that we have created this new person data. This is our structure, and then this is another struct that we store whatever this collection here. Then it will store with this byte here. This is a byte, guys. So the Gob encoding, it will return you with the encoded bytes. So this one normally you cannot understand because understand the text is not a plain text, it's a byte, like it's a computer generated um, encoded bytes, guys, so we cannot understand this. Right now is it translates into this byte. So in the map, as you can see, if you imagine our map now, there's only in there's always have these keys and values in the collections of map in the map. So there are only two uh, columns there, or two fields there, as always. But right now, our key is the username, and after this is the byte is the more. This is our value for this key. So actually, this is our exact data with these multiple data here from a struct. So we go back again. In this right now we need to encode immediately. We need to store with another variable. Then error, we need to check always, especially these bytes, guys. We need to use the what they call the encoded payload function that we created earlier. Then with this person's data, as you can see how I use this data here, the struct, we fill in all the data, the information, like this parameter, the username, the first name, all these inputs. The moment that we collected all this information, then we use our custom function. There is a gob encode. As you can see here, this is our gob encode. So gob in new encoder, then it will encode the bytes there, guys. These are all standard from gob encoding bytes, encoded bytes. So then we encode the payload. The payload is the persons there, the struct. As you can see that this is the struct here. This one. So we encode whatever data in this struct that we have collected. So right now we go back again. Then after this we need to the standard error, guys, not equal to nil, and then return with the false because we have a boolean. Then the error, just throw the error there to the user. Then we need to add the PD there. These PDs we add to the collection, to our map. Then the username, then the encoded bytes, guys. This one. But after we encode, this will return us with the byte. As you can see, our own function there. It returns a bytes and then the error. That's why we have these bytes and errors here as our variables. Then if any detected errors from during the encoding, then it will just return false. Then it will not proceed to this line of code. So it just block here. Right now, this one is a bytes already, guys. As you can see, this is a byte. Now we can add. Then we return with the true and then nil. Now as you can see, we want to use already, guys. We want to use the thing. Okay, guys. To capture our time, I added this to add the new struct, guys. Then this is just to add a new row, guys. And then we have to decode. This is how to decode, because this is the parameter is just a username. So to demonstrate to you guys, this is the D here is the person already. So we can just extract whatever the person there. As you can see, the first name, last name, username, email, whatever the data there. Then we can just extract, guys, back. I want to display also this D or whatever, guys. So okay, so this is the format. And then I added this decode. This is how we can use the decode payload that we have created. This is the custom function that we have. Then to demonstrate to you this first name, and then if we remove, then we can just use the PD that remove, guys. This one is just our information. Then we need to check the decode again if the username AAA is still exists or not. Then we just return. So if you run this, okay, so the value is there, guys. A new person has been added. Okay, then John, all these for example is the information, and then the username remove AAA. Then as you can see, because we remove already the AAA, but when we try to decode again, the username key is not found. This is from our error there, guys. So our own custom errors. And then the first name then is empty already. So because we deleted this AAA, and then right now we decoded, guys. So it's no worries already. So this all the things. So I hope you enjoy. Okay, that's all for today, guys, and I hope you learn a lot here in Maharlikans code. The Gob Encode is a very powerful one, because in terms of programming in Go, because this Gob Encode is you can find it in Go programming languages. It's very unique for Go. So this is very important, because you can transmit data into into the networks or something like that, to preserve all the data from the struct, and then you can decode it and then use it later on. But the main thing, guys, is you need to preserve the Golang struct, whatever you have the structure there, like the last name, first name, username, whatever. The moment you encode it, then encode, and then that state of the struct, all its values and data is all preserved. It's all encoded into the binary there. And then after that, when you decode it, but when you have that struct change or something like the new field change or remove, then that time you cannot decode the thing. So you cannot decode the exact value already, because you do not know the exact structure, because you change it. So that is the only pitfall for these guys, for the Gob Encode, because the last state you need to preserve it, bundle it together into one binary. The moment you extract it to get the data, then the reference struct there is no longer the same as the moment that the Gob Encode capture and that state. So all the last name person, if you remove the last name, then when you decode, then your last unless you want to change the, unless you change the, what you call, change back the original structure of the struct, then you can decode it again. The what you call, the Gob encode is you can extract again the data. So that's all for today, guys. And if you're new to my channel, kindly subscribe to Maharlikans Code so that you can receive more videos like this. And see you in my next video here in Maharlikans Code. We still have more videos lined up here for getting started in Golang, so that we can I can impart to you some of my knowledge here. Okay, guys, see you, and bye bye.